this equation where you have found yes, anything which is having motion or a particle which is having motion, it also exhibit wave character. That is, it is explaining the dual nature, wave as well as the particle nature. And from there we have got the de Broglie's equation. De Broglie's equation is being given lambda is equal to h by p, where lambda is de Broglie's wavelength, h is the Planck's constant, and p is the linear momentum. Or we can also write, linear momentum is nothing but the product of mass and the velocity. So we can also write lambda is equal to h by mv. And after that, we have done the derivation of the de Broglie's equation, and this we have obtained by combination of Max Planck's equation and Einstein equation. Okay, so today we are going to do another one. This is called Heisenberg Uncertainty Principle. Heisenberg Uncertainty. Okay. See, Heisenberg was initially in Germany. So after the Second World War started, they left. Einstein, Heisenberg, all of them, they left Germany because Hitler was penalizing those people who are not obeying him. So they shifted to America. And later on, he has become the chairman of the Atomic Commission. And under his thing, only the atom bomb was being made. Heisenberg Uncertainty Principle. See, before that, let me explain something. See here. Suppose it is a very crude way of explaining. See, suppose these are the running track. Okay, these are running track. See, you can view them either standing here or standing here. If you stand here, then you can make it out who is running fastest, because you know that he is the one who will be nearer, he is coming nearer to your vision. But if you stand here, you can find their position. You do not know at what speed they are running. Okay, with what speed you are running, that is the one you can find their position. See, you have seen, no, that whenever this type of sprint or anything comes out, and how do people know that who has come first from there? If you'll find one person is here, and also a camera is being fitted. So from there you can find out who has touched the thread there. Okay, so Heisenberg has mentioned it is not possible to know exactly the momentum and the position of the particle correctly. You cannot determine both of them accurately. Either you will know the momentum of the particle, or you will know the position of the particle. That is called Heisenberg Uncertainty Principle. Wait, I'm giving you this definition. Yeah. Okay. So you can write it is not possible to measure simultaneously both the position and momentum, or we can write what? Velocity. Why? Because particle momentum is mass into velocity. Mass of the particle, you know it accurately. So what would be doubtful? Velocity. Of a microscopic particle with accuracy. This is the one. Mathematically, delta x into delta p is greater than equal to h by 4 pi. Okay. So what is delta x? Uncertainty in position, and delta p uncertainty in momentum. Okay, we'll write P is equal to m in. Okay, I'll as linear momentum equal to mass and velocity of particle. Therefore, P is equal to m into. So this is equation 1. Let us substitute it here. So what will write now here? Therefore, delta x into delta mv greater than equal to h by 4 pi. See, there cannot be any uncertainty in the mass. Mass is always fixed. So therefore, what I can write? Therefore, delta x into delta v is equal to h by 4 pi. So this is the equation. I told you after writing, then you have to tell me. Finished?
Yes, sir.
See now, then what is the relationship between Heisenberg uncertainty principle with the structure of atom? So we cannot write anything anywhere, na? So we have to think, why should we discuss Heisenberg uncertainty principle? So with my little knowledge, I want to tell you, we have mentioned that this is a nucleus and this is the electron. We have found that electron revolve around the nucleus in a circular orbit, and electron in different orbit has different velocity, and these are fixed. So see here, we know the velocity of electron, and whenever it moves in circular orbit, wherever its position is that, but that is also fixed. Why it is fixed? Because the distance from the nucleus is always same. Distance from the nucleus is always same. So in that case, it is not obeying Heisenberg uncertainty principle. See, atomic structure we have mentioned that that Bohr's model of atom does not explain Heisenberg uncertainty principle, because in this case velocity is also fixed, mass of the electron is fixed, that is, its momentum is fixed, and each position from the nucleus is also fixed, because in a circular orbit radius is always same. So in that case, when we apply Heisenberg uncertainty principle, then you will find that actually electron does not move in a circular orbit. See, so this is the nucleus and this is our orbit. This is the one. So when electron moves, dear, electron moves in this. See, this is the wave. Heisenberg uncertainty principle has explained that electron has dual nature. It has linear moment, it has momentum, as well as it is having uncertainty position. See here, each and every moment, the distance of the electron from the nucleus is changing. So because of that, we should take into consideration Heisenberg uncertainty principle. Okay. Now, today we are going to do numericals. We'll do one to simple. After that, we'll go to others. Okay. I know none of you are doing numericals by yourself. Huh? You thought what the sir will take, and after that you will take rest. Huh? If those who are in the inertia of rest, life itself will be totally spoiled. So we'll do a very simple one. Calculate the frequency of an X-ray having a wavelength of 1.5 into 10 to the power 10 meter. Do. Calculate the frequency of an X-ray having a wavelength of 1.5 into 10 to the power 10 meter. So what equation you'll use? What equation you are going to use to calculate this one? What is frequency? Nu is equal to what?
1/10.
No. You forgot everything. Nu is equal to
H by P.
P by lambda. What is C? C, then nobody will tell you. You have to remember. C is the velocity of light is equal to what? P into 10 to the power 8. Huh? Meter second inverse. So find out the value of this lambda. You see, both of them are in meters. You don't have to convert. Find out. Use calculator. Don't do manually. How much did you get?
So it's a 2 into 10 to the power 18.
Yes. What will be the unit? Unit will be nu will be equal to 2 into 10 to the power 18 hertz or cycle.
So
All right. Then do the next one. Calculate the energy of 1 mole with quantum. The plural of quantum is quanta. Radiation of, not of, whose frequency is 5 into 10 to the power 10 to the power 10 second inverse. Please remember the Einstein equation. Not Einstein, Planck's equation. It says E is equal to h nu. But that is only for only one quantum. Okay, this is for only one quantum. So energy for one quanta of radiation E, you have to multiply it by Avogadro's number. So n into h into nu. Value of n also you know, h also you know. So put and get it. What is the value of n? Don't remember. N value will not be given to you. You have to remember. It is a very, very popular one. What is the value of n? Hey, why you are keeping silent? If you don't know, you tell. And h is equal to what? 6.626 into 10 to the power minus 34 joule second. Put the value and get it. So what is the result? How much is the result?
So is it 199.54 into 10 to the power minus 1?
So I got around 20 joules. That was 1.995 into 10 to the power minus 19.
Minus how much?
19, sir.
No.
Sir, I got around 20 joules.
It is, yes, 19.95 joule. 19.95
Yes, sir.
joule. They have found now per mole, so it will be per mole. Result is 19.95 joule See what they're saying. 1 mole, no? You write now here mole inverse. Okay. Now next. What do you know here? The Broglies wavelength is what? H by P or lambda V. Okay, so let me write it here. The mass of electron is what? What is velocity? One percent of c equal to what? See, 1% of the speed of light. Put and get it.
So is it 2.43 into 10 to the power minus 10 meter?
Yes. Let others also do. Only one person will not help. So all of you have done it.
Yes, sir.
Yes, sir.
No, sir.
Then finish. Time is very less. I told you to use calculator. We are not using, na? Hundred kg rocket. Calculate the wavelength of 100 kg rocket moving with a velocity of 3000 km per hour. Comment on the result. See, velocity you have to convert it into meter per second. So this is the information I have given you. So you know lambda is equal to h by m. Mass is no problem. You can take in kg. Convert velocity 3000 km per hour into meter per second. Do it separately. Then you put the figure here and you will get the result. After that, I'll tell you how what is the comment. These sums are simple. So did you get it? Why you are taking so much time?
So is it 7.95 into 10 to the power minus 40 meters?
Yes, correct.
Sum two I got the same.
7.95
95 into 10 to the power minus 40 meter.
into 10 to the power minus 40. Okay, meter. Now see. Look at this weight. It is so small that we can say the rocket is having a linear motion. So we'll write now here. The wavelength calculated is so small. So it can be assumed as the rocket is having a linear motion and not a wave. Why did I tell you to comment? The reason is that de Broglie's concept or equation is applicable only for microscopic particles. Microscopic. Rocket is such a big object. See, when you travel by a car, does it go like this? It doesn't
No,
go
sir.
like this. It goes straight. So, de Broglie's concept is applicable for microscopic object. So, what we can write? We can write hence. Only microscopic object can not follow, obey de Broglie's equation. This will be given just to know whether you have understood the theory or not. Simple calculation will not have because you have to comment on the result that you have obtained. Then you will say, no, this is de Broglie's wavelength is not applicable for larger objects. Even for cricket balls also it will not be. Not. When you go for playing cricket ball, it directly goes and land. It may be bounce to some other direction, but it never goes like this. Assume if the cricket ball is to come like this, no batsman will be able to play. Okay. So now we'll do some numericals from Heisenberg uncertain. Calculate the uncertainty in velocity of an electron if uncertainty is 1 angstrom. Okay, so 1 angstrom is equal to what? You know the value of 1 angstrom. It is 10 to the power minus 10 meter. So what we will write now here? We know delta x into, I'll write here, I'll not write delta p, huh? I'll write direct delta b is equal to h by 4 pi. So what is delta x? Delta x is 1 angstrom equal to 10 to the power minus 10. Mass, so you know, equal to 9.1 into 10 to the power minus 31 kg. See, if this comes in centimeter, then you have to write it in gram. Okay. Now you have to find out velocity. What is the value of h? 6.626 into 10 to the power minus 34 joules second. What is the value of pi? 3.1 or 22 by 7 or what? Or 22 by 7. Which one you want, you can use this. Okay, so now find out delta V. Who is singing? Dinesh. बोला असं काही गेलो.
So is it 5.794 into 10 to the power 5 meter per second inverse?
Yeah, meter second inverse. Velocity will come meter second inverse. Okay, let others also do. Electron has a speed of 40 meters second inverse. Accurate up to 99.99%. What is the uncertainty in its location? This sum is very common for your exam. This. Write it, then I'll explain to you. Then see here. What does it say? This is uncertainty in position, and this is the uncertainty in velocity. So you are supposed to find this. They have not mentioned anything about the uncertainty. Suppose one information, some of your friend asked you, do you know this? So you have told, okay, I know it. Then he will ask you how much certainty you can say. You will say, I think 70% certain. If 70% is the certainty, then how much is the uncertainty? How much will be the uncertainty?
30%.
30%.
30%. How did you get it? It is 100 minus certainty.
70%.
100 minus certainty. So 100 minus how much of the certainty? 70. So what does it say here? An electron has a speed of 40 meters second inverse, accurate up to 99.9%. Means, then what is delta V now? Delta V is 100 minus 99% of 40 of, let me write it right here, 40 meters second. So how much it comes? It will be how much? It will be 0.01% into 40. So equal to what? Is equal to 0.01 divided by 100 into 40. So this is the way they will give you. Now find it. You have to find delta x. This value just now I have written. All these values I have written. Mass of electron also I have written. So get the values from there and write it. Some of these informations you have to know. Values of constant you are supposed to know. They will not give you the values of constant. Mass of the electron also you have to know.
Done, sir.
So what is the result?
Sir, 0.0144 meter.
Yes. Then we'll do one more.
So what is the mass?
150 gram.
Thank you, sir.
No. If the uncertainty in its position is of the order of 1 angstrom. So you know 1 angstrom is equal to what? 10 to the power minus 10 meter. See here, it is in gram. It is in meter. So you have to convert gram into kg.
So 3.51 into 10 to the power minus 24 meter per second.
So now you see, it is 3.5. See, with this apply scientific brain. Minus 4 means what? I should put how many zeros? Minus 24 is what? It is 1 will go. I have to put 23 zeros. So let me write here. 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 3, 5. Do you think it is uncertainty or certain? Huh? If such less is the uncertainty, that is, it is certain. What does it mean, dear? That Heisenberg uncertainty principle is applicable for microscopic particles. If the particle size is bigger, Heisenberg uncertainty principle is not applicable there. So write down here, below the result, you'll write the uncertainty in its position is insignificant. Hence, macroscopic particles do not follow Heisenberg uncertainty principle. What should you write? The uncertainty.
तबीयत कैसा है रे? ठीक है दादा.
Uncertainty
काफी टाइम हो गया उससे मिले हुए.
position is insignificant. Hence, it can be mentioned that macro means large. Macroscopic particles do not follow Heisenberg uncertainty principle. Remember. Okay, so you should understand. See, this is uncertainty to what? Huh? It is nothing only. Okay then, bye.